All right, welcome back. We're ready to dive into section 2. And by now, you've taken your notes, you've done the assignment on section 1, and now we're ready to tackle section 2, solving inequalities. And today, we'll be doing this with adding and subtracting. So, once you get this heading down, then I actually want you to write down this very, very obvious statement. -3 is less than 8. Now, back in chapter 2, when we were solving equations, I said anytime you see an equation that we're going to solve, I want you to put a little line under the equal sign so we can keep track of doing the same thing to each side. And I want you to do the same thing here. Except this time we have a less than sign instead of an equal sign. Let's start out by tackling and adding, let's add 10 to each side and see what happens. -3 plus 10 gives me 7. 8 plus 10 gives me 18. And when I look at this, I say, well, yes, indeed, 7 is less than 18. Okay. Even if I tried something just crazy large, like maybe I added 100 to each side of the inequality, then what happens here? On the left-hand side, I have 97. On the right-hand side, I have 108. And the inequality is still preserved. It stays the same as less than. So what it seems to indicate here is that no matter what we would add, as long as we added the same thing to each side of this inequality, it's going to preserve this less than relationship. Okay. Put a squiggle line under there, and I actually want you to write it one more time here. -3 is less than 8. This time, instead of adding, let's try subtracting something, such as something like 5. So if I subtract 5, and I perform this subtraction on each side of the inequality, I'm doing the same exact thing here. On the left, I end up with -8. At the right, I end up with 3. And, yes, indeed, it's still less than. Even if I went hog wild crazy and decided to subtract 100 from each side of the inequality, on the left-hand side, I'd have -103. On the right-hand side, I'd have -92. And yes, sirree, Bob, it's still smaller. It seems that no matter what I add or what I subtract, as long as I do the same exact thing to each side of the equation, or the inequality in this case, my relationship is preserved. It stays true. And that actually is the big moment here that we're going to talk about and use today, is that there are some main properties of inequalities that we are denoting to be true. And the first one has to do with addition. And basically, here's what this property says. If you add the same value, or the same quantity, I'm just going to say value here. It could be a number, it could be actually a variable, to each side of an inequality, Ooh, I apologize. It gets a little difficult sometimes to write on this little slate device. And each side of an inequality, it remains true. In other words, the inequality relationship remains true. So if you started with less than, it stays less than. If you had greater than, it's greater than. Less than or equal to stays the same. Now, we also just discovered that it appears the same thing happens or remains true with subtraction, and you're exactly right. This property of inequalities also applies to subtraction. Now, rather than write all of this same verbiage again, I'm just going to say this. I'm not going to say ditto, but I will say it also remains true. So subtraction, if we subtract the same value from each side of an inequality, It also remains true. Well, that's great because now we're going to be faced with some examples and we'll be able to use this property to solve the inequality and graph it. So let's do a couple of examples and then I'll turn you loose. Here's the first one. Write this down. X plus 12 is less than 20. I like to get in the habit of putting this line underneath my inequality. I say, oops, here's my variable x, and I need to isolate x. And to do that, I need to undo whatever is happening to x so that I get it by itself. Plus 12 and minus 12 are opposites. They go to 0. X plus 0 is 0, or is x. 20 minus 12 is 8, so here's my solved inequality. X is less than 8. Graph it now. Here is, always show me 0. 8 is somewhere here to the right. I'm going to use an open circle because it's just a less than symbol for my inequality. I don't fill it in. I need you to shade to the left of 8 to indicate less than, and fill in the arrowhead. So your graph should look like this, open circle at 8 with shading to the left. All right, let's try another one. D minus 5 is greater than negative 7. I'll put my line here. There's my variable. I want to get it isolated or by itself, so I am going to add 5 to each side of the inequality. Be fair and do the same thing on each side. A minus 5 and plus 5 go to 0. Now I just have D on the left-hand side of my inequality, and negative 7 plus 5 is negative 2. Done. Illustrate the solutions by graphing it. Because D greater than negative 2, there's an infinite number of solutions to this one. Show me where 0 is. Here's negative 2. I put a circle here, and I'm going to leave it open because my symbol is greater than. There is no equal sign. This one, however, said greater than, which means I need to shade to the right, and I'm going to fill in the arrowhead to indicate that that goes on into infinity. All right, one more example here. Oh, decimals! Awesome. Here is my inequality symbol, so I'm going to put my line down the middle here. This time my variable's on the right. It's a variable n. So what I'm going to do is, in order to isolate that variable, I'm going to add 3/10. And I'm going to do the same thing on the left-hand side, because you have to be fair. Do the same thing over there. When I add on this side, I get 1 and 2/10. When I combine these like terms on this side, they go to 0 because they're opposites. So now I end up with 1 and 2/10 is greater than or equal to n. Now, in all honesty, if you want to leave your solution like this, technically, that's okay. But I've told you I cannot read backwards very well. I like to put my variable on the left-hand side, which means I'm going to have to make it a less than or equal to symbol because the smaller end was pointing toward my variable. Here's 1 and 2/10. I prefer saying it this way because now it's easier for me to graph. When I get my number line, here's 0, here's 1 and 2/10. I put my circle at 1 and 2/10, but this time I will fill it in because I do have the equal sign, and I have to go less than, which means shade to the left, and put in, whoopsie, put in a big arrowhead. I gotta clean that up a little bit. Fill in the arrowhead as well. Again, make sure that your circle is filled in. Granted, this isn't very neat because I'm using this tablet to write on, but you get the idea. Alrighty? Now, originally I was going to have you do some pages out of the workbook for some more practice, but I think you're ready to roll. So I'm going to turn you loose right away to today's assignment, which is on page 177 to 179, and these selected problems. Awesome. Go ahead and get started on that, and once you come back to class, you can check your solutions with my work here. Good luck!